So chapter 6 is about systems of equations. Systems of equations are when you consider more than one equation at the same time to get a solution. So literally you're finding the solution for one and the solution for other and see if they have any in common. And this whole chapter will be dealing with that. So first we're going to, in lesson 6.1, we're going to learn how to graph systems of equations on the coordinate plane. And by graphing them, we're going to be able to determine what solutions they have, meaning what solution they have in common. Here's your vocabulary: system of equations, consistent, independent, dependent, and inconsistent. So go ahead and make a list of those so you have them, and then we'll fill in the blanks as we move along through this lesson. All right, trying to turn the page. Here we go. All right, so let's see an example of when you'd use something like this just in a general way. You don't have to take notes on this. This is just something to think about. So a band looks at the cost to produce a CD. And to begin the production, a band has to pay $1,500, and each CD costs $4 in addition to that to produce, and they will sell the CDs for $10. So the band wants to know how many CDs they will have to sell to earn a profit. So what we want to find out is how much does it cost to produce, how much money will they make selling, right? And we could graph each of these equations. One equation would be the blue line here, which says y equals 4x plus 1,500. It's 1,500 is the initial setup on the CD and $4 for each CD, right? So that's their cost. And this y equals 10x is they make $10 on each CD that they sell. So the red line is how much money they make. Where they intersect right here is the solution of the system of equations, and that is the magic number where their costs have met their earnings, and from that point on they would have a profit. So that's how you might use a system of equations. Okay, so the two equations are called a system of equations. So the definition for a system of equation is two equations. It's probably better to look it up in your glossary. They'll have a nicely worded one. But basically, it's two equations that are solved for a solution that works for both equations. A system of equations, of two linear equations, can have one solution, it can have an infinite number of solutions, or it can have no solution. So we will look at how those graph differently. If it has one solution, as the case in our band CD sales, it only has one solution. So that would be one solution. And if we graph something and both lines were exactly the same, you can imagine it would be an infinite number an infinite number. And if we graph something and they were parallel, they would never intersect. There would be no solution. Okay, if a system, and here's some more vocabulary for you, if a system has at least one solution, it is said to be consistent. The graphs intersect at one point or are on the same line, okay? It has at least one. It could have more than one, right? Remember what at least means. Or they could be the same line. So that's what consistent means. Now, in a consistent system, they can either be independent or dependent, okay? And if they're independent, there's only one solution. That means there's just one solution, all right? If they're, let me see if I can move this guy. If they are dependent, it's an infinite number of solutions. If a system has no solution, it is inconsistent. So we have consistent and we have inconsistent. And under consistent, we either have independent or dependent. So you might want to take your notes, graph like that, to help you break down what these words mean. Okay. You guys like my Beatles theme? I thought that was make it slightly more interesting, right? Okay. Here is a look graphically at the possible solutions of systems of equations. So if you have exactly one solution, it could be consistent and independent, okay? If you have an infinite number of solutions, it's consistent and dependent. And if you have no solution, it's inconsistent. So maybe your homework is going to be to look at a graph and describe it, meaning is it consistent and independent, is it consistent and dependent, or is it inconsistent? So here, something like that. Use this graph to the right to determine whether each system is consistent or inconsistent, and if it is independent or dependent. So we have y equals negative 2x plus 3, and y equals x minus 5, and we're considering those two together. So if we look at this graph, y equals negative 2x plus 3, which is the green line right here, right? And y equals x minus 5, which is the purple line here. They intersect at just one point. So therefore, you would describe them as consistent and independent. All right, I'm going to erase these lines. And now let's look at the second one. Okay. Now we have y equals negative 2x minus 5 and y equals negative 2x plus 3. So here's y equals negative 2x minus 5, and here is y equals negative 2x plus 3. You'll notice they're parallel, right? So these parallel lines, there will never be a solution because they will never intersect. Therefore, this system is called inconsistent. All right, here's some guided practice 2 problems. Graph these and determine if they're consistent and independent, consistent and dependent, or inconsistent. This is just a study tip. Use it if you'd like. Don't need to use it if you don't want to. But when both equations are in the form y equals mx plus b, the values of m and b can determine the number of solutions. So if you look at two equations, y equals mx in y equals mx plus b form, if they're different m's, meaning if they're different slopes, there's only one solution. If they have the same m value, that means they're parallel, right? And there's no solution. If they have the same value, m value, and a same b value, right? So then that means that there are infinite number of solutions. I should have added the b value, that there are different b values on this one right here. Okay. Solve by graphing. One method of solving a system of equations is to graph it. So, and then we have to, this is why rulers are important, guys. Accuracy is important on these, okay? Because if you carefully graph it, you can find the point of intersection, and that will be your solution. So let's try this. Graph each system. We have y equals negative 3x plus 10. So that means m, the slope is negative equals negative 3 over 1, and b equals 10, right? And for our other one, y equals x minus 2, our slope is 1, and our b is negative 2, all right? So let's first graph this one. Let me move this guy out of our way. Okay, so first we'll grab negative 3x plus 10. So I'm going to count by twos, 2, 4, 6, 8, 10. So there's b, and the slope is negative 3 over 1. So I'm going to go up 3 and over 1. Oh, it's a negative slope. My bad. You know, I'm not going to count by twos. I think that might confuse you guys. I'll just count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's our intersection, right? And the slope is negative 3 over 1. So over 1, and it'll be up here someplace. So let's go down 3 and over 1 to here, down 3 and over 1, down 3 and over 1, and so on. So we have something like this. Mine isn't going to be accurate because I don't have a ruler to use on this smart board. But yours will be, right? Be very careful you get the intersection right at where you need it. Okay, and y equals x minus 2. So the slope is 1, b is negative 2. So here's negative 2. That's where we're going to start. We're going to go up 1, and it's a positive slope. Up 1 over 1, up 1 over 1, up 1 over 1. Up 1 over 1, up 1 over 1. Okay, so I'm guessing right here is our intersection. So the solution, or the answer to this system of equations is 1, 2, 3, comma 1. All right? Here, let's try another one. All right, 2x minus y. So now we're going to have to take 2x minus y equals negative 1 and put it into slope-intercept form. So minus 2x on both sides. And we get negative y equals, those cancel out, negative 2x minus 1. Divide by negative 1, and we get y equals 2x plus 1. So m is 2, and b is 1. So we'll graph that. So b is 1, and the slope is a positive 2, up 2 over 1, up 2 over 1, down 2 over 1. Looks, whoops. Let me see if I can do a better job of that. That wasn't very pretty. Oh, b was 1. My bad. Well, it's not the best line, guys, but that's the best I can do. So this is y equals 2x plus 1. And now let's do the other one. 4x minus 2y equals 6, minus 4x on both sides. And we get negative 2y equals negative 4x plus 6. Divide both sides by negative 2, and we get y equals, divide by negative 2, 2x plus minus 3. Okay, and we'll graph that. So m is 2, and b is negative 3. So here we are at negative 3, and a slope of 2 over 1. So we'll go in a positive slope, up 2 over 1, up 2 over 1, up 2 over 1. So this is y equals 2x minus 3. So we can see that they're parallel, which we could see because they had same slope, different y-intercepts. No solution. They'll never intersect, so they will have no common solution. Here are a couple for you guys to do. Good luck with that. And I think that is the last slide of the day, sure enough. So there are your guided practice, and We'll talk about it in class. We'll have a worksheet to do in class tomorrow on this.